Okay, a very good morning to my fellow friends, and I'm Chee Hau, Justin, and our cameraman Chun, and we are here today to explain you about the optical fiber and how the light is transmitted inside the optical fiber. Okay.
Okay, how's the light is propagation in the fiber. So now we'll see the explanation of the structure by the Chee Hau first.
Okay, so firstly I will start to explain the structure of optical fiber, and yeah, I let you have a look at the picture. Okay, so this is what optical fiber. Okay, and yeah, so firstly we have the core, the most inner part, the core, cladding, and then the jacket, cladding, core. Okay, the main function of jacket is to protect the whole fiber. Okay, and then the cladding, we can say that the main function of the cladding is to ensure that the light is able to transmit throughout the optical fiber. Yeah, so from the theory view, the refractive index of the cladding must be lower than the core. Cladding must be lower than the refractive index of the core. Okay. Yeah, and beside of that, the light ray is should be totally propagate or transmit in the core, but not in the cladding or anywhere else. Okay, yeah, and to achieve that, we have a factor called the acceptance angle. Acceptance angle is an angle which ensure the incident light, which is the light that carries the information, to be guided by the core throughout it. Okay. So now I would like to ask Justin to continue.
Okay, for me, I will explain the occurrence of light propagation, which occur in the part of in the core part. So I will draw the two boundary. Okay, this is the normal, and N2 and N1. N1 is the refractive index inside the core, whereas the N2 is the refractive index outside of the core, which in the cladding part. So, okay, what is meant by incident angle is the angle in which the incident ray is transmitted. For example, this is the incident angle, and refracted angle or the transmitted angle is the angle after it passes the angle reflected after it passes through the boundary between two medium. So yeah, this is the refracted angle, and this is the incident angle. So the transmitted angle can be categorized, can be divided into either is refracted or refracted. So when the incident angle is occur at a point, that when the refracted angle is equal to 90 degrees, which the right angle is called the critical angle. Okay, in which the refracted angle is equal to 90, and this is what we call as critical angle. So after that, when we increase some more the incident angle, when the incident angle is greater than the critical angle, total internal refraction will occur. And this is how it occurs in the optical fiber. Okay, so now I will pass to Chun to proceed with the propagation part.
Okay. So now yeah, let us see who is Chun.
Yes, I'm Kachu, and now I'm going to present how actually the light is propagation in the fiber. So let's say this is a core of the optical fiber. So by applying the concept of total internal reflection light, so the light will be reflected like this. And then you can see the normal light is actually like that. This is the normal line. Then you can see the angle of incidence is over here. Angle of incidence, and then the angle of reflection. So after it reflect again, it will show another angle of incidence and another for angle of reflection. And the situation will be go on until here. So which means that the data will not be losses to the other medium by applying the total inflation concept inside the fiber optic. So this is an overall explanation by us on how actually the light can be propagation in the fiber optic.
Okay.
So we'll end our discussion here, and thank you very much for watching here.
Thank you.